You must have come across this particular term, reinforcement learning, definitely, because this is so popular that it's almost impossible to escape from this particular term. Now, when we say reinforcement learning, what does it mean? So, it means the science of decision making, and ultimately, you are trying to achieve the optimality in this decision making process. So, how you are going to define this optimality, how you are going to make a decision model, how you are going to optimize your model periodically, all these things related key concepts, the sort of algorithms available, and the related papers where you can find them. All these things we are going to discuss in this particular video. So, stay tuned. Hey there, my name is Rohit Kumar, and we are going to focus specifically on the reinforcement part in this particular video. So, let's start. Jumping on to the specific behavioral model. So you can see the model like this, that you are having an environment, you are having an agent, and the state and the reward are coming from the environment and going to the agent, and the agent is recommending some sort of action to the environment. Let me simplify it. That suppose you are working in a specific field and that field is having hundreds of sensors or something like that. We are working on a sort of autonomous communication model. Then the current state of the environment means how many operational nodes are there. Suppose 100 nodes are there. After some time, only 90 remained operational due to low battery life, 10 got dead. So the state got changed. Additionally, if you want to give some sort of reward, means you want to amplify the battery of a particular node, then the respective link quality or the weightage will get improved. All these things will come into picture. So the state and the rewards are going to get changed periodically over the period of time. When these will change, there will be a computing element called agent, which will take the decision based on the current state of the environment. So it will give the suitable action so that you move into the direction of optimality, and ultimately you achieve your destination goal. So what is the destination goal? The goal is just to achieve the optimality. So there should be a optimal function, means optimality function, which is going to guarantee you the optimal behavior of the network. So with respect to all these details, yeah, unless you see a research paper, you cannot see the actual behavior. So just let me show you one of the papers. There are hundreds of papers available on reinforcement learning. Because of its popularity, it's a very popular subject in AI domain. So, in this work, the people have focused specifically on reinforcement learning and different sorts of functional concepts from the point of view of modeling, from the point of view of optimality they have defined in this particular work. So, let's go step by step. So, as we saw that there was a model with respect to environment, there was an agent, similar sort of model is also available here. We are going down. They are showing that the kind of communication environment and agents are having in between. Then they have defined the models of optimal behavior. That is very much important, because if you don't define the optimal behavior, how the function is going to get work. So you are going to define that we are going to achieve this. But the point is that specifically when you are saying that model is doing something, means it is learning, then how you are measuring the learning performance? So that becomes a question. So there are two important things, that there should be the convergence towards optimality. Means if you are not converging towards optimality, you are going in a different direction. So always make sure that you are moving into the right direction and you are ending onto the optimal solution. Secondly, the speed of convergence should be good enough. Means if your speed of convergence is very slow, then the model performance will be degraded. So that should not be the case. Model should be moving into the right direction, as well as the model should be sufficiently fast. So these kind of things are related, and these are the kind of things available over here. Additionally, with respect to these things, there are different sorts of strategy, the reward system, the kind of policy making, their policy iteration, and then computation of the results. All these things are available in this particular work. You can go and have a check yourself. The bit lengthy paper, close to 50 pages are there, but there are a number of references are also available. So the meaningful there are close to 40 pages, but still it's a lengthy. So if you are kind of a beginner into the field of research, then I will recommend you to go to the specific section which interests you most, and then slowly when your interest get built, then you can read the whole paper. So that's the idea of reinforcement learning. And there are some related things which are related to reinforcement learning. Let me highlight those also, because when we are going into the field of reinforcement learning, we should see that there should be a concept of maximizing cumulative reward. Ultimately, there is a reward system, there will be a cumulative reward, and based on the requirement, you can go into the direction of maximizing it. Then there are different sorts of data sets which are available for reinforcement learning. So if you are interested, you can go for the FinRL meta. You can go for SNAC version 2. You can go for the room environment version 1. You can go for Avalon. You can go for QDAX. And kind of thing that you can do, you can have a multi-objective reinforcement learning, because it is not always necessary that you have a single objective function. There might be multiple objectives, and that's why you can formulate a multi-objective optimization policy. Based on that particular policy, you will define a particular optimal function, and you will define all the related parameters so that you are moving into the right direction. So that's the basic concepts. And now coming on to the specific paper details. So I have shown you one paper, that was the survey paper. There are different implementation based papers also. So if you are going with respect to reinforcement learning, then there is a work proposed in ICML 2017. It's a TensorFlow implementation, and the title is a model agnostic meta learning for fast adaptation of deep networks. So here they have used the fast adaptation based work. So depends on the kind of priority, whichever work you are considering, just to see whether it is lying in your research interest or not. Additionally, there is another work of ICML, and it is also based on TensorFlow implementation. The core point is the soft actor critic of policy maximum entropy deep reinforcement learning with a stochastic actor. So again, the kind of what is the maximal pointer? So here they are going for the maximum entropy. So as I told you, that there should be an objective, and you should try to optimize it. So based on your objective, you'll redefine your policy again and again. You may need to shift your rewards into the right direction. Additionally, the agent need to generate the right sort of input for the environment reproduction. So all these things are available. Number of papers are available. These are just a few examples. You can go and have a check on Google Scholar for more details. That's all from my side. Hopefully you must have liked the video. If you didn't like anything, please do comment below and criticize the video. We'll incorporate your suggestions to improve the quality further. Thanks for watching. Happy learning.